In this video, we are going to focus on revision exercise 10.1, measures and mensuration. You will find this on page 550 in the Namibian Ordinary Level Mathematics textbook, Y equals mx plus c to success. Now, this is actually not a very difficult chapter. There's just a few extra, like the cone and the sphere and the pyramids that's coming in. But the nice thing, they will give you the formulas. So if I just, before you start with it, if I'm just going to give you a little bit of advice, I will just say again, you just have to run very briefly through the basics. So make sure you know measures. Make sure that you know these tables. And I love these tables because it always works. So make sure that you just go through that tables. Volume, mass, okay. It's not just for mathematics. It's also for physical science that you're going to use that. Okay, time usually is not so difficult, also not so much asked on this level, and I think you are more used to that than you think. Okay, very important. This is coming from grade 8 and 9, so very, very important. Just make sure that you memorize these formulas. Say, how do I work out the perimeter of a triangle, the area of a triangle? Now, I'm not even going to go through it. I'm just showing you. It's a square. There's the formulas. Make sure you know it. Rectangle. Memorize it. You have to memorize it. There's the perimeter, there's the area. You can use one of these two. It's base times that perpendicular height or half product of diagonals. Parallelogram, the same. Base times height, sharing with the rhombus or the parallelogram, and I just add 2 length plus 2 breadth, basically. But just make sure, just run very quickly through all these formulas. It's coming from grade 8 and 9. Then the circle, and please don't get confused. So if you're going to look at the circle, the perimeter, or they call it actually the circumference, but I'm just going to say P now. It's 2 pi r. Then the 2 is on the ground. That is the distance around. And if it's the area, it's pi r square, then that 2 will be on top, because remember, area is always centimeters square, kilometers meters square, it's always there. So don't make 2 pi r square. There's not a formula like that. Then it's 2 areas that you're referring to. So very, very important there. And then, and I just want to show you to make sure, if you come to a sector, and this is also not very difficult, also very easy, and I'm just mentioning it very briefly. So if you just want to find the length of the arc and you just want to find that part, you just need that angle. And that angle, so say for example it's 60 degrees, then it's 60, let me just write it down, then it's 60 over 360, because it's a point, 360, and you just take the normal. If you want the length, which is the perimeter or the circumference, it's the normal 2 pi r, the normal one. Just multiply the fraction of that. And the same with area. Okay, so make sure, I'm showing you now, here it comes. So just go through that basics very quickly, and it's also standing in the summary. If it's the area of a sector, now it's the part that's colored in, this part. So the area of the sector. And again, it's the angle. So say, for example, that angle was 60. Then it's 60 over 360 times pi r square. And now it's going to be on top. Okay, so you just use the normal formula and multiply it with that fraction of that out of 360. That's easy stuff. Okay, and then I just want to very briefly, that is more or less, and you can look, combined figures, this is all coming from 8 and 9. I just want to, 3-dimensional shapes, that's prisms. Now a prism, just remember, a prism keeps, it's almost like, and I always like it to tell the students, if you put it through a bread slice machine, then this slice will be equal to the middle slice will be equal to the end slice. So the shape stays the same. The shape stays the same to the back. Okay, and if it stays the same, it's a prism. And don't forget, the general formula for the volume is always, so the volume of a prism, it's always area of base. So if it's a square, it's side times the height. Or length times breadth times the height. So you just work out the area and you multiply it between the difference or the distance between the two bases. Okay, and then think the net, if you start folding it open, and I think it's just good that you have a picture of this. Maybe just showing you here quickly, run through these blocks. It's always telling you. So if you fold this open, you will get 6 squares. Do you see there? And then if you fold this one open, you will get also 6, but this 2 will be equal, this 2 will begin, this 2 will be equal. Just for the interesting. Say, because you have 3 sides, length, let's make it breadth, and height. And if you look at the 3, then I'm just going to say, for example, it is now 15, and it's 7, and it's 20. Now the formula, because there's 2, so the total surface area, and I just want to show you this. It will be 2 length times breadth, plus the other 2, so say for example that 2, plus the other 2 length times breadth, plus the other 2 length times breadth. And now I just want to show you how I fill it in. It's very nice then. I take the first 2 and I put it, okay, let's do it like this. First going to say 2, and there's 2 values, plus 2, 2 values, plus 2, 2 values. And then I'm just taking the first 2 times the next 2 times the first and the last. Do you see? So take the first 2, fill in. Take the second 2, the last 2, fill in. Take the first and the last, and that's the total surface area. Okay, that I just wanted to show. The cylinder, don't forget the volume. I'll just quickly run through here. Okay, let's just make it smaller. Okay, it's too big. Okay, the volume is the same. It's area of base times height. And then if you fold it open, you get this. But don't forget that that part fits there. Okay, so basically, if you're just going to do, that is the circumference, and the circumference is 2 pi r. So that one will also be 2 pi r, and that will be the height. And that's why if you want to work out this curved surface area, it's going to be, and let me just see, where did I write it? Very nice. This is the total surface area. So it's going to be the bases. And how many bases are there? Okay, I'm using another method there. There is 2 bases and then the curved surface area. So 2 bases, so 2 area of circles, and then 2 pi r, that's the circumference, and then times that height. That's actually easy. And again, triangular prism, you can just work it out according to the triangle. So please just go through that formulas, otherwise you're going to struggle. And then all that I want to show you here, this, and I think I'm rather going to go to the summary, because okay, so let's look at the summary. There is 3 new ones, or this is the sphere, the pyramid, and the cone. Now what is very nice is that they will usually give you these formulas for the volume, the total surface area, the volume, the total surface area, the volume, the total surface area. And basically just going to do substitution. So just remember, a sphere is like a tennis ball. Please don't forget that a hemisphere is a half sphere. Okay. Just remember that if they talk about the word hemi. Okay, and then basically you take the formula and you just substitute. And then the same with the pyramid. because this is the same as this two is actually the same. It's almost like it was a prism, but then it was shaped. So that's why they use that is the formula for the prism. Area of base times height. But now, because it is shaped to a point, you just multiply it with a third. So it was also, let's use the volume, because it's area of circle times height, but because it's shape, you multiply with a third. But again, they will give you the formulas. And then the total surface area, please don't forget that the pyramid, and you will see it nicely, if the base is a square, then it's just making these triangles. Okay, and this, and then you can just work out base times height, and you work out all the triangles, and you work out the area of the square. And then don't also forget, and this is also one thing I just want to point out, this is having two. This height is called the perpendicular height, and it's indicated with a H. But this is almost like an L. It's called the slant height, and you can work it out. How can you work it out? I think it's better to read. By using, that's 90 degrees, by using Pythagoras theorem. So if they give you, you just play around. If they give you this one, you add, square and you add. And if they want you to work out of the short ones, you square the hypotenuse and you subtract one of the short ones. So just think of Pythagoras theorem. Okay, I think that's enough, just quick refreshment. And now I just want to very quickly run through these basics. Okay, some of them are coming from grade 8 and 9, but I just show you my method. Oh, look at this, nice. What is this? This is not the one I'm going to do. I'm going to do the other one. But do you see it's a pyramid? It's with a base of square, and there is my triangles. But I'm in a next video, not this year, I will do 10.2. Other year. For now, I will just do 10.1. Okay, so calculate the area of a circle with a radius of 3.7 centimeters. If you don't know the formula, you get 0, because you cannot do it. I showed you now, area of a circle, and that is where the 2 is on top. It's pi r square. Now you can look on top of the question paper, in the beginning of the question paper, they will tell you what to use pi. They can either the one on your calculator or 3,142. Okay, so if you want, you can use the calculator. Otherwise, you're just going to substitute 3,142. And what is the radius now? I gave you the radius. 3.7. This is so easy. If you just remember to memorize the formulas. And it's not difficult. You did it a lot of times. 3.7 square multiply 3.142 equals. And what will I get? I will get 43. And if it's three significant figures, 0.0. That is what I'm getting. And that is centimeter square. Can you see centimeter square? That's why the square is there. Remember it like that. Now the next one. A can of tomatoes is a cylinder with radius. So just take note that this first one will help you in the second one. So they tell you that that radius of all of them is 3.7. That's what they are telling you there. And the height, okay, can of tomatoes is a cylinder with radius centimeter and the height h. I don't know the height. The volume of the cylinder is 430. Let's calculate h. It's a bit more difficult, but it's just algebra. Because the volume of a cylinder, and what did I say? This is a prism. It's area of base times height. So this will be the area of the base. And what is now, you can use this value. Do you see? You already worked it out. Otherwise, you must say again pi r square and substitute. No. You already worked it out. But otherwise, if somebody is not getting it so fast, you can substitute it in there. It's fine. It's fine. As long as you come to the answer. And then multiply. And what is the height? The can is and the height h centimeters. But if I look at this, it's 2 cans. Oh, these 2 cans. Oh, I don't have the height. But I have the volume. What is the volume? 430. Okay, and now to get that height, it's just algebra. 43.0, and I just divide. And they wanted me to use that because, oh, look now, then I get, so therefore, the height is going to be 10 centimeters. And I want to repeat, and I don't want students to feel if they don't catch it this fast that they are not good in maths. So if you want to again write pi r squared, that is also 100% correct. It's just if you worked with this three significant figures that you will get this nice one. So don't let it discourage you. You can also do maths. So calculate the value of h. And then number B, this is nice. You will get these nice things. 12 cans fit exactly into a box. 3 cans long, 2 cans wide, and 2 cans high. So it means there's 2 rows. Do you see? There's 3 to the back and there's 2. So actually, write down the length, the width, and the height of the box. Okay, now just be careful. Be very careful. That was 3.7, that was the radius, but I'm asking you, what is the diameter? The diameter, that one, will be 3.7 times 2. Do you agree? Because it's 2 radius. And that's 7.4. So meaning, if that is 7.4, that will fit exactly. So you can go and you can say, let's call, and now it doesn't matter what, let's call length, okay, because how many cans can fit 2? So this is actually more like a square, but it doesn't matter. Let's call this length, let's call this breadth, and now, then I think it will be the other way around. Let's rather call this length, this breadth, and this height. Okay, so I was working out now the breadth. So I'm going to say the breadth, and did you see what I was doing? The breadth, it will be that it was actually 3.7 times 2, and the breadth will be 7.4. And now, don't forget, this is every time that I'm working with that, I just want to see 3.7, no, I just want to redo it, sorry. Oh, this day is also becoming too late. Okay, I just want to write it better, because if I write it better, you will not make mistakes. So let's write the radius is 3.7. The diameter is 2 times 3.7. And that will give me that 7.4. So the breadth will be, the breadth will be 2 cans. So that will be, because I'm working with the diameter, it's 2 times 7.4. And if I say 2 times 7.4, 7.4 times 2, and I get 14.8. Just want to see quickly. I'm just seeing that I'm to the dimension. It's 7.4 by 3, 14.8. And then I'm going to do it here. I can go and I can say the length is 3 cans. The length is 3 cans. So that will be 3 times the diameter, because there's 3 fitting. I'll show you here. That's 7.4, 7.4, 7.4. So it's 3 times 7.4. And if I take 7.4 times 3, I'm getting 22.2. And then the last one, and I like to do it now next to each other. Okay, the last one will be the height. And the height will be 2 cans. And that will be 2 times, oh, the height is also 2 cans. Okay, so the height is 2 cans, But almost I made a mistake. Because there's 2 of them. So let's just see. 2 times, I think the height, it's 2 times 10, the height of 2 cans. I think that is going to be correct. I know. The height. That is not the radius. The height of each can. Oh, this day is becoming too long. The height of each can, that height was 10. And then this one will also be 10. So it will be 2 times that height, 10. And that will be 20. Okay, was this all in centimeters? Let's just see if it was a bit in centimeters. Yes, it's all in centimeters. Okay, it's not that difficult. Just remember, I almost made a mistake with this because there I must work with the heights. And then calculate the volume of the box. So I'm going to move it a little bit up. Volume of the box, it's a rectangle. So it's length times breadth times height. And there's your breadth and your length and your height. So it's going to be 14.8 times 22.2 times 20. And if I press it on my calculator, I get 14.8 times 22.2 times 20. And my answer will be 6571.2, and that will be in cubic centimeters. Okay, it's exact, so I'm going to leave it like this. And then the last question on this. Let's just do that last one. Okay, oh, so high. Okay, so if you look, calculate the percentage of the volume of the box occupied by cans. Now, just be careful. How many cans are in the box? So there are 12 cans. Can I just go a little bit down? Because there's 6 on top and 6 at the bottom. That's 12. What is the volume of 1 can? I think I must first work out 430. They gave it to me. The volume, can I show you? Where did they give it to me? That's going to be 430. Okay, so if I'm moving up again, so it's going to be, so therefore, volume equals 12 times 430, and that will give me an answer of 5160 cubic centimeters. And now I move on. What did we say? What was the volume of the whole box? Do you see? This is the whole box, the blue. This is the volume of the cans. And they asked me, calculate the percentage of the volume of the box occupied by the cans. So if I just want to do it I'm just going to put the cans. So I'm just going to say volume. I'm going to call it like this. I'm going to say percentage occupied. And that will be that 5, this is the cans, over the total, 6571.2. And to make it a percentage, I just times with 100. And if I'm correct, I'm going to get 78.5%. So the rest of that, up to 100, is the open spaces between the cans. Okay, that's not that difficult. And I really think this is a nice question to ask. Just my personal opinion. Okay, but if you don't know your basic, if you don't know the area of a circle or the volume of a prism, you're not going to be able to do that. So let's do number 2. I'm going to move it just up and then clean again. Number 2. In the quadrilateral ABCD, BC is parallel. Okay, let's just go. BC is parallel to AD. AB is this, BC. And they gave me all the information. Everything is filled in. So nice. And then they asked, write down the mathematical name of the quadrilateral. Now, the only property is that one pair of sides are parallel. Then it can just be a trapezium. So please, that was with angles. Chapter 8, quadrilaterals, you have to learn that names. Okay. And then, now they bring also chapter 9 in. And this is actually how they like to do it in an examination. They bring in different chapters. Use trigonometry to show that the height is 5.2. So I have my 90 degrees. So they want me to work in this triangle. Okay. Now, let's see what I have. Just think of trigonometry. There, my little man is standing. Okay. The long one, if that's 90, that's 90. So that will be the hypotenuse. That will be the adjacent. And that will be the opposite. Okay. So if I'm going to start with number B, then I'm just going to say, okay, who is playing, who's in this game? The one asked and the one given, and you are out. And then I write down my word. So, ka, to, a. And then I'm just looking. Okay, now if I'm looking here, opposite and hypotenuse, oh, it's going to be sin. So I'm just going to say sin of how many degrees? 70. Remember opposite on top, hypotenuse at the bottom. So opposite is h over hypotenuse, it's 5,5. And if the unknown is on top, then it's going to be h is equal, it's a multiplication. But first write the side and then multiply sin 70. And then if you press it on the calculator, make sure your calculator is on degrees. Sin 70 equals, and I get free significant 5.17. Okay, and that's in centimeters. Okay, so h, therefore, h is that. Then I go on, calculate the area of the quadrilateral A, B, C, D. Now, can I just quickly check here? And because I am going to need, so I just want to see, multiply 5.7. Okay, so I want to see what do I have, what do I don't have. Oh, okay. So how do I going to work out the area? It's going to be 8 for, oh, that's so easy. How? The formula, just the formula. Okay, let's do it. Okay, what is the formula for the area of a trapezium? So easy. Half height, sum of parallel sides. It seems to me sometimes you always sides, and that was also in your tables. So what is the height? I worked it out now. That was that 5.17, and you can use the approximated one. And what is the parallel sides? It's going to be 8.4 plus 12.5. Okay, and then I'm just going to press it on my calculator, and that is going to be 8.4, okay, 8.4 plus 12.5 equals, multiply 5.17 equals, divide by 2 or multiply a half, and I'm getting 54. Actually, I'm getting this. I just want to show you. But if you approximate, then it's going to be 54, because that one stays a 0, and put it 0 because you must approximate it to 3 significant figures, and that is centimeters squared. Okay, and then number D, and I have to make space for D. Then I'm almost through with one page. Like that. The previous videos were so long, and I still have 2 challenging chapters, which I want to do today. Okay, so let's look at number D. And that's 2D. The quadrilateral forms the cross-section of a prism with a length. So that is just going 3-dimensional. Calculate the volume of the prism, give you an answer correct to 2 significant figures. Now, I think it would have been better, and I know I shouldn't, I'm just going to leave and not clean. Again, it's my video. I can do that. I'm rather going to move up because it's not a long sum. And I'm going to use that answer. And this is the reason why I reverse back. Because the volume of a prism is just area of base times height. And what I already worked out the area, there's the base. And what is the area of the base? And use your answer, 54.0, doesn't matter, multiply, and what do they tell me is the height? 6.8. And I'm basically just going to press that on the calculator, and I'm just going to get, it seems to me there's an E also, 554 times 6.8, and that is going to give me, if it's exact, 367.2. But let me see. Give your answer correct to 2. Oh, you must always underline that, otherwise you're going to forget. So then it's going to be 1, 2. Look at the one behind. This is a 7, so it will become 1 more. So it's 3, but don't stop there. Fill up to the point with zeros. So the answer will be 370, and that will be in cubic centimeter. So please, I think this is good advice to give you. In the examination, as soon as you finish with the answer, just take the question part and read it again. And then you will not make the mistake to forget to approximate it to 2 significant figures. So just make sure that what they were asking, you were answering. Okay, let's do the next one. Oh, no, it seems to me it was the last one. I don't know if there was an E. Oh, don't seems to me here is E. I don't see it anymore. Okay, I think it was just that one that we used. I think there's a mistake. Okay, so let's just move on to the next one. Now I come to my the sphere and the cone. And as I said, they will give you the formulas. Did I give you the formula there? Yes, I gave you. It stands in the syllabus. I must give you the formula of the sphere. But this is a cone. Can you see it's a cone? A sphere is like a tennis ball, and a pyramid is like in Egypt. Remember that pyramids. So the diagram shows a cone of a radius 4 and a height 13. It's full with soil to grow small plants. Each cubic centimeter of soil has a mass of 2.3 gram. Very important. Okay, calculate the volume of the soil inside the cone. So it's just asking you the volume of the cone. So let's just write it down. The volume of the cone and that is going to be 1/3. It's actually easy because it's like a prism, but it's just a third of a prism, of a cylinder. So in a cylinder will be area of base times height, which will be pi r squared, because the base is a circle, times the height. But they give it to you, so just fill it in. So it's a third. I like working with 3,142, but you can work with the real pi in your calculator. And the radius is 4, and the height, and remember, this height is referring to the perpendicular height, which is 13. And then if I'm just going to press it on my calculator, I'm going to say 3,142 times 4 times 4 times 13 equals, divide 3 equals, and I'm getting on my calculator, I'm getting 217.845. It's always good to write it, but then approximate it to 3. So 2, 1, and then this 8 makes this one also 8. And that will be in cubic centimeters. So that was my A, and it was the first one. And now I will go to the second one. Okay, so calculate the mass of the soil. Now just remember, one cubic, so has a mass of this, and this is the amount of cubics, and you can work with the approximated one now. So it's just to say the mass, I'm just going to take the total mass and I just multiply it with the mass of one cubic. And that then I multiply it with 2.3. So then I just say 218 multiply 2.3, and I'm getting 501.4, And that is just 218 times 2. I just want to see. My calculator is giving me something different that I see in my teacher's guide. So 218 times 2.3 equals. No, I don't think I'm incorrect. I think it's correct. I just think I'm tired and I'm not looking nice because it stands in the teacher's guide 501. And that is going to be in gram. Okay, that was the mass. And then calculate the greatest number of these cones which can be filled complete using a 5 kilogram. And there comes the measuration. So it's always good to first know your tables. This is a nice one. The table is just going like this. It's ton, and then it will be kilogram, and then gram, and then milligram. And between them, it's so nice. It's just 1,000 and 1,000 and 1,000. And if I go to this side, I multiply. If I go to this side, I divide. So now, what am I converting? I'm converting 50 kilogram. So, and then I'm in gram. So I must go from kilogram to gram. Can you see? I must follow this road. So I must multiply with 1,000. And then I get 50,123 gram. And now I can do my calculation. And I just move it up a little bit. And now I know that this is for 1, and I want to see how many of that cones I can fill. So I can set the number of cones, therefore the number of cones. It's just going to be that big bag, okay? Make sure your units are the same, gram, and you can work with that approximated value. And if I do that, I'm just going to get 5, 1, 2, 3, and I divide it 501, and I get 99.8. Okay, but now you must start thinking. Okay, they are asking you, calculate the greatest number of these cones which can be filled completely. So you cannot do 100. There's not enough. It's almost like you have to take the full number before 100. So therefore, I think they call it rounding down. Okay, but therefore, I'm just going to say only 99 cones can be filled completely. So it's not just maths, it's a practical sum. So you have to think practical. You don't have enough to make a full one for that 100 position. So you just have to go to the full ones, which was 99 cones. Okay, okay, let's do number B. It's still part of this question. It's now just number B. Now here comes the word. A similar cone of height 32 is used to grow in larger plants. Now people, this is similar figures. So basically, I'm just going to use now similar figures. So I can say, I'm just going to say the big, oh no, let's rather do the small on top. Say small, and I'm going to put it over the big. And now, usually and if I can recall, it was that triangles, can you remember? And then I said it's similar triangle DE. I'm just refreshing your memory. So it was AB over DE equals BC over EF, and then first and last over first and last. You remember that? And then you were ticking, and this one. But now they just give it to you a little bit different, but they still give you 2 of it. And can I just show you? It's not really, and they like bringing it here in with cones, similar figures. Okay, so just remember small over big. Now, it's almost like the height, now let's say the small height over the big height will be equal to the small radius over the big radius. So if I look, what do I have? Okay, remember this one is small and the one they are talking here is big. So if I'm going to say the small height, now what is the small height? It's that 13. What is the big height? It's 32.5. What is the small radius? It's 4. What is the big? That's what I'm looking for. I'm looking for the big radius. You can even call it x. And now, what do? I just cross multiply. So let's work with the x. So I say 13x equals 4 times 32.5. Pen is not working. 32.5. And now I'm just going to divide 13. So it's 4 times 32.5 equals, divide 13 equals, oh, this is excellent, it's 10. So therefore, let's call, say, the big cone radius equals 10. I need it, okay, because now I'm going to go further. And I just do exactly the same as I did. I want the volume. So calculate the volume of soil used to fill this, the volume of soil. So give your answer correct to 2 significant figures. So to find the volume, I'm just going to say, again, it's a third of a cylinder. So area of base times height. But they gave it to you. Yeah, they gave it to you. And then it's 3,142. And what is the radius now? It's 10. And what's the height now? 32.5. And then I'm just going to multiply it. It's 3,142 times 10 times 10 times 32.5 equals, divide 3 equals. And I'm getting, let's just quickly see. Yes, I'm getting 3403.83. And if I'm making it to 3 significant figures, and don't forget 1, 2, 3, then it will be 3400, and that's cubic centimeters. Okay, and now give your answer. Oh, no, I'm not correct. I'm not, again, can you see? Read the question, and I'm actually used to reading the question at the end to see if I'm, so give your answer correct to 2 significant figures. Actually, I was correct, I think, according to that, but I would rather count 1, 2, this is a 0, so this stays a 4, so, and then fill with zeros until the comma, and this will be correct. Okay, but still read your question, especially if it's word sums, to make sure you are not leaving out something. And then the last one, so nice, if I come to the last one. Okay, I'm going to use values maybe, but luckily I have it in front of me also. Let's just do that last one. Number C. Okay, some plants are put into a cylindrical container with height 12 and volume this. Calculate the radius of this cylinder. Now, this is a prism. Now, how do I calculate the volume of a prism? All prisms. It's area of base times height. And now just fill in. What is the volume? They gave me the volume. 550. Okay, let's just see if I'm, okay, I just want to see what is the radius. I'm looking for the radius. Okay, so can I just fill in this formula here? Volume, so it's pi r squared times height. So I'm just going to fill in